Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I will choose question 3 from chapter 9 to do this video. So in the question they ask determine I naught in the circuit, and we know that we should use phasor to answer this question. So we will check the circuit if it is all in phasor. So in power supply, the equation is 60 sine 200t plus 80. So we need to change into cos. So we do this graph. So we need to change to cos. So cos to sine clockwise and minus 90. So the new equation phasor we get 60 cos 200t 80 minus 90 is equal to negative 10. So in the phasor we will get 60 angle of negative 10. Okay, next it also have inductance and conductance. So inductance in Henry and conductance in Farad. So we need to change into phasor form. So to change inductance, we'll use this equation, this formula, J omega L. So J is the imaginary. So omega 200 times 120 millihenry. So we'll get 24J. And for conductance, 1 over J omega C, where 1 over J is negative J. So 1 over 200 times 15 micro. So we will get the answer minus J 333.33. So we have changed all three in this phasor form. So we will redraw the circuit with the phasor format. So this inductance J24, this conductance 333.33J, and this power supply is 60 minus 60 angle of negative 10. So we should now calculate the impedance. So for impedance equivalent, because this is the series, so we just add. So 24 plus minus 333.33, we will get 3 minus 309.33J. So this is the next circuit. So we'll get the answer just now. So because this and this is a parallel, so we should use this equation. 1 over Z equivalent equal to 1 over 100, because this is 1k ohm. So we do not need to change. So 1 over 100 minus J 1 over 309.3. So we have calculated in the calculator. The impedance equivalent is equal to 87.33 minus J 282.32. So this is the next drawn circuit. We have this and this 2k ohm. So same like above, this is a series, so we should add. So 2000 added with 87.33, because it is a real part, so it will give us 287.33 minus J 282.32. So this is the impedance equivalence, and we have the power supplies, and we need to find I naught. So we use Ohm's law, V equal to Iz, and we this and I naught, we will get I naught is equal to V over Z. So V just now 60 angle of negative 10, and over Z equivalent 287.33 minus J 282.32. So this will give us the answer of I naught is equal to 0.0285 angle of negative 2.3 ampere. Okay, that is for chapter 9. Okay, so for chapter 11, I will choose question 6, where they ask to find the equivalent impedance, average power, reactive power, apparent power, complex power, and power factor. So like just now, we should change all into the phasor form. So power supply is already in course, so we need to change the inductance and conductance. So first, for conductance, we know the formula is 1 over j omega c. So we just put the number 1 over j, omega is 2, and conductance is 0.25. So we'll get the answer is negative j2. So for inductance, the formula is j omega l, where we put the number, so we'll get j times 2 times 3, and that will give us j6. So we draw the circuit and put the value we get just now. So this is negative j2, this is 2 ohm, so this is series, so just add it together, 2 minus j2. So this is parallel, so we need to use this equation. 1 over impedance equivalent is equal to 2 minus j2 plus 1 over j6. This we get just now, j6. So we calculate, and the impedance equivalence, we will get 3.6 minus 1.2j for this. So this is 1 ohm, and it is a series, so we just add together. So for the first question, the impedance equivalence is equal to 4.6 minus j 1.2. So in the phasor form, we will get 4.754 angle negative 14.62. So that is the impedance equivalence. So to find the power, we need to find current, because power is equal to VI, where voltage time current. So to find current, we use this Ohm's law, where V is equal to IZ. To find current, we rearrange the equation. So V over Z, V just now in phasor form, just add it, just put the number 8 angle negative 40 minus Z equivalence, we get just now 4.754. so we calculate, so we will get the current 1.68 angle of negative 25.38. So we have settled for current and voltage. So we need to find the average power. So we use this equation. Average power P is equal to half Vm times Im cos theta V minus theta I. Theta V minus theta I. So we just include the number, half times Vm 8 times Im 1.68 cos negative 40, and minus, this is negative, so it become plus 25.38, and we calculate, we will get the 6.5 watt for the average power. Okay, next, the next question is reactive power. So we can get using this root mean square. So first we change Vm into V root mean square. So Vm divided by square root 2, and we'll get 5.657, and for current root mean square we will get 1.188. so reactive power is equal to V root mean squared times R root mean squared sine theta V minus theta I. So we put the number into this. So 5.657 times 1.188 sine negative 40 minus become plus 25.38. So we'll get the reactive power is negative 1.7 VAR, because Q is lower than 0, so it is a leading. Okay, next, the complex power. The complex power. So for complex power, we can get the answer. We can get from this S is equal to 1/2 times Vm times Im conjugate. So we will conjugate this I, and we will get 1.68 angle 25.38. We just change the symbol. So in this, we just, like always, put this number. V is equal to 8, I 1.68, angle negative 40 plus 25.38. So we will get the answer 6.72 angle of 14.62 VA. So this is the complex power, and we can check these two from this equation, because we will change this into the A plus BI format, and we'll get 6.53 minus J1.7. So for this front, it is a real power or average power, so it is same like just now. And for this reactive power, we will get same. So this is how to check. So next, the apparent power is, we just take the magnitude of this 6.72, so we will get 6.72 VA. And last, the power factor. So power factor is equal to cos this angle, negative 14.62. So the power factor is 0.968, because the angle is below 0, so it is a leading. So that's all. Thank you.